Good morning, everyone, and welcome to our first virtual Corteva Seed Grower Combine Clinic. My name is Stacy Rampton, and I am the soybean production agronomist in Manitoba. I also have the pleasure of being your moderator for this morning's meeting. We thought we would try something slightly different and have a very informal, interactive harvest clinic as close to harvest as we could get it without impacting everyone in the field. Today's topics of discussion will be specific to optimizing combine settings on John Deere combine models and offer some insightful storage considerations. Now, I can only speak to Manitoba, but I think in general, a late start to planting was something that many folks on the call dealt with this spring. And knowing this, we wanted to get ahead of planning for a delayed harvest. Typically, a late harvest for us in Manitoba means combining higher moisture grain in low to declining temperatures under wet cutting conditions. So the experts on this morning's call are going to lead you through ways to fine tune your concave, fan, and sieve settings for seed soybeans specifically, how to adapt to changing conditions throughout the day, and ultimately achieve top quality seed production from both an appearance and integrity standpoint. There are a lot of quality factors that we can control at harvest and even improve once that product has hit the bins. So if we can be at all prepared for how to handle the potential fall changes we might encounter this year, I think we should continue to improve our overall seed quality. So to start us off this morning, I would like to introduce you to the combine expert himself, Scott Hildebrand. Scott grew up on a grain and cattle farm by Crystal City. He's a certified mechanic and started as a technician at Green Valley Equipment back in 1997. He has many years of experience with service and repairing John Deere machines and has been with John Deere for about 25 years. About 10 years ago, Scott transitioned out of the shop and into a product specialist role with a focus on in-field equipment optimization, adjustment, operator training, and demos. Scott is a really busy guy and offered some top-notch customer service today, so we are very grateful to have him join the call. I do have to apologize. I did not hit the record button until a minute into Scott's presentation, so you will find this meeting will start kind of abruptly and might be a bit choppy. I will put together a summary of Scott's information so you won't miss out on any of the items discussed during this meeting. So enjoy. From future Stacy. Bye.
600 RPM range. Okay, so yeah, rotor 5 to 600. We're going to start around the 550 mark. Concave around the 16, 17, 18, somewhere in that range. Cleaning fan will be about 1,000 on our S series machines, and anything older, so 70 series and a little bit older, it's usually about 100 RPM less. So let's say about 900 or so on the fan. Chaffer and sieve settings about 16 and 5. And then for the guys that are running the S series machines, you have that separate section of top sieve. We call that that dual zone chaffer portion. And that in the soybeans, we want to set to, well, somewhere between 5 and 8. It's mechanically set. So it's that 10 millimeter wrench you need to hop in the back and kind of adjust that portion. But typically, if I take a handful of soybeans and just kind of dump it on top of that sieve, you want the beans to be able to easily slide through. But we want to close that up as much as possible to prevent any extra pods or any things that we don't want clogging up our tailing system. So we keep that as closed as we can, but big enough to drop the seeds through. Feed accelerator settings, we're going to be in slow for soybeans. Nothing new there. Feeder house speed. So when we're running our straight cut headers with the guys with the variable speed feeder houses, I mean, they're forced to be in low speed. But on the right side, we still have that adjustment there. We got the 2 different sprocket sizes on that front right corner. So we're going to want to be on that small sprocket, which drives that feeder chain as slow as we can go to minimize the seed damage, and it still has ample speed there to move that material along. So, oh, and then there's one more, I guess, for those S series guys. There's that active tailing system. So the return system that's no longer dumping back to the rotor. We got the corn and the grain setting there on that little decal. So For the most part, we're going to be in the corn setting on that active tailings, on that rethresher. There are situations where we get some stubborn pods and have a tough time kind of threshing some of those out. So we can go to grain in those situations. You just got to be aware that you can run into a little bit of extra seed damage by doing that. So for the most part, we're going to be in the corn position there. So those are just some basic starting points. You know, as well as I do, they're going to vary a little bit from year to year and field to field, but that's where I would hop into the season to start off. So I want to expand on some of those a little bit. Given those settings, the numbers are kind of only as good as what they're. I guess the numbers only represent what it thinks is physically set to. Okay, so if we look at our sieves and concave settings, these are just measured by a little sensor, a little potentiometer sensor. And every time we have a potentiometer, there's an opportunity for a calibration. So we want to make sure that our numbers jive on your display to what they're physically set to. So it's very important to know that, so that your settings are what you think they are. So this is something I run into all the time. I get called often to come out into the field and check combines, set them, help guys out, get a better sample, get our losses down. So the first thing I'm going to usually do is crawl in the back of that machine and just verify these sieve settings. Because if I'm recommending settings of 16 and 5 and you're actually measuring 20 and 9, well, your result in the tank and the back of the combine are going to be very different than what I would expect. So just verifying that the numbers are what they say they are is quite important. And that number is actually a measurement in millimeters. It's not just a generic number. It is actually a physical millimeter measurement. So if I'm saying that, yeah, it's important to check this, how do you do it? Well, I guess the simplest way is in the cab, I would set both your sieves to a setting of 5 millimeter. And then I always carry with me a piece of 5 millimeter key stock, about 12 inches long or so. And so if they're set to 5 in the cab, I can run back and physically measure those sieve openings with a piece of key stock to make sure that the physical measurement lines up with what the display is saying. I mean, you can use a drill bit or an Allen wrench or anything that measures 5, but that is the best way to verify this. If it isn't right, if you find that you are way out, a calibration is required. You do have in your calibration menus of these combines, a lot of you do have the option for sieve and chaff for calibrations. It might sound a little silly, but I'm going to discourage you from doing those, because those user-facing calibrations often make things worse. The calibration that you actually need is kind of in the factory technician mode. So if the cal is required, I'm going to get you guys to call your dealers for the info on that. I won't go through that here today, but refrain from using those user cals, because they can get you into trouble as well. Okay, so hopefully that kind of makes sense on those sieve settings. I really also wanted to touch on have a little discussion here on fan speed and sieve settings, because there is a direct relationship between the two. So a lot of guys will try to clean up a dirty sample, get rid of some unwanted pods in the tank by choking off and closing down the sieves. Although this can work in certain situations, one of the keys that I've learned over the years is understanding how the air moves through that whole cleaning system, and to make that air flow and direction work together with those sieve settings, we can do a better job of cleaning. We can do a better job of managing losses by controlling that air flow, controlling that air direction, versus trying to only close off sieves. Okay. So I guess what I mean by that is the farther open that we have our sieve settings and our louvers, the more vertical air movement we have in that cleaning chute. And we want a good balance of vertical and horizontal airflow. So if we're choking off the airflow, the vertical flow too much by a closed louver, we're going to end up a lot more horizontal airflow, which is going to push that product out the back of your combine, and you can run higher losses that way. It's going to affect your grain tank sample. And that vertical airflow is very important in getting that initial separation between the mog, the chaff, your pods, and the seed. So personally, I'm a big fan of controlling tank sample and grain quality in the tank by using more airflow, wind speed, rather than choking off the air with sieve settings. So even the bottom sieve, the more you close down that bottom one, we're restricting how much air gets up to that top one. And if we don't have enough air on that top one, the mog kind of sits on top of the louvers. It doesn't get that mog up into suspension. And if it's not up into suspension, then everything gets carried out the back of that machine. So a higher fan speed typically, and probably some wider sieve openings than what you normally run or what you would think is okay, is probably what I would recommend, especially here with the soybeans. So a concern that I often hear when I suggest this is that, well, if I crank up the wind speed, I'm going to blow seed out the back of the combine. There are cases where that can happen, but it's a matter of balancing that higher wind speed with the proper opening on your louvers. So if we're not getting enough wind, that seed gets carried out with the mog. But if we give that extra vertical air blast, then we get that separation of mog and seed. The seeds can settle out and the mog gets carried out. So something to try. I know instinct tells us, oh, we got pods in a tank, let's close up the sieves, but I would suggest let's try it a little bit differently and play more with fan speed and instead of choking down the wind, because wind speed and direction has a huge impact on what's going on back there. The next thing I want to discuss a little bit is concaves. So I think for the most part, it's widely accepted that the large wire concaves are the concave of choice for soybeans, and I would agree with that. That is our best option. It offers the best threshing while minimizing seed damage. So there are guys using the round bars. Round bars work okay, especially if conditions are really dry. I'm not anticipating that to be the case this year. I'm thinking things will be a little bit, we're pushing the dates and pushing the envelope a little bit. It might be on the green side. So I'm not recommending round bars. Sometimes with the rounds, we have to get a little more aggressive on the concave clearance to be able to do a adequate job, and then we still end up with seed damage because we have to squeeze it too tight to get the job done. So large wires is what I'm suggesting. Given the date of the soybean harvest this year, it's going to be later into September, and if we're switching back and forth between our coarse grains and small grains, often or more often than we normally would, something to consider would be a combination of concaves. So we've had lots of guys do this in past years as well, where we're running a small wire up front and then a large in the middle and the rear. And we're finding we can run that in all crops. We can run that in the wheat, we can run that in the canola, and seems to be doing fine in the soybeans as well. So if it's something that you're going to be swapping back and forth several times in a season, from soybeans to maybe canola later on, that's maybe something you can try to eliminate that extra work and time that it takes to do that swapping. So definitely something you can consider. So I think I've maybe talked enough on combine settings. I do want to touch on header a little bit, because the header is also very important in accomplishing what we're trying to do out there in the field. So one of the first things, I'm assuming everybody's running flex headers. So there's auger headers and there's draper headers out there. I'm sure there's a variety of header types that I'm speaking to, but again, most should apply to everything. The reel tine angle. So on each side of the reel, you got that adjustment. There's 5 or 6 holes there. We can adjust the aggressiveness of those reel tine fingers. And I am finding that does have a huge impact on how that header performs. I was demoing in a soybean field last year, and my first pass, we were making a terrible job, and beans were short and having a hard time getting into that header. The only adjustment I made was I made those tines more aggressive, and we turned that header from a dog into a rock star. So small settings like that, they have a huge impact on getting that crop transition from the cutter bar up into either the auger or the drapers. For the guys on the draper heads, I'm going to recommend a draper speed that I feel works the most effective. So in that 170 to 180 RPM range is where I would recommend and suggest running those drapers, okay, for the best performance. The auger headers have a couple other adjustments, especially if we're going to have a little bit damp or a little bit on the green side. You know, wrapping can be an issue both on the reel and around that auger drum itself. So there are some adjustments there on that auger drum. We got the stripper bars underneath and one in the back. So it is very critical on those to have them set to that 1/4 inch spec. So that's an adjustment that needs to be checked going into soybeans. And then those retracting fingers in the center, what we're looking for there is about a 5/8 of an inch gap from the end of the finger to the floor when that finger's at its tightest point. That adjustment is made on the right side of the header. You're just rotating a cam, but that is an important adjustment to prevent wrapping around that center drum and to transition that crop from header to feeder house. The next one is cutter bar angle. So every one of your machines, we are capable of adjusting that cutter bar angle, whether it's tipped down forward a little bit or rotated back. So the newer machines, we can do this hydraulically. Most of your machines, they're mechanically adjusted. We can adjust that front face plate, the header attachment plate on the front of the feeder house where the header attaches to. So when we're adjusted correctly, that cutter bar is going to be pointed slightly down when that header is sitting on the ground and riding on those skid shoes. That's where it's going to be operating at its most efficient point for both cutting and preventing leaving crop out there. A more aggressive angle there is it's going to get us closer to the ground to get those low pods. And it's also going to act as a crop lifter if we got some down stuff. But it is a little more susceptible to getting stones in that head as well. So we got to be a little careful when setting that. It's more of an issue if you're tilted back too far. You're going to be very inefficient on that cutter bar. You're going to be leaving standing beans in the field. You'll see plants standing in behind the header. It's usually a good indication that that's tilted back too far. So that is an adjustment available to you that I do suggest you play with and set to where you need to be. Okay. A couple more things. The real clearance to the cutter bar. I know sometimes in that really short crop, we would like to get that reel a little tighter to keep that crop moving off of that cutter bar. But because of the way these Deere headers work in flex mode, that cutter bar actually hangs down and is separated from that reel. So something I've learned to do is where we do have that short crop. Just 1 second. Yeah. Sorry, guys. Yeah, and that short crop where that reel doesn't want to move that material in. It just helps to manually lower that head, which collapses that header right to the ground momentarily. That reel will grab that material and push it back. And as soon as you release that manual button, your auto height control takes over again and keeps going. So just a little tip there. I don't think short crop's going to be an issue this year, but there's always hilltops and some drier areas where maybe that is an issue, and that's a little tip that I use to help when that material starts building up on that cutter bar. So one of my last things then, I do want to talk Hydroflex pressure. So all your headers are Hydroflex, or most of them. So a common question I get is, what pressure should I be running? So before I say that, I do want to kind of explain a little bit what that pressure is actually doing. So, because some guys don't understand what's actually happening here, but simply put, the more pressure we put into that cutter bar system, all we're doing is we're lightening up that cutter bar. So we're just changing the weight of that cutter bar with hydraulic pressure is all we're doing. So a higher pressure makes that cutter bar lighter. A lower pressure makes that cutter bar heavier. So a starting number would be in that 12 to 1300 PSI. And I'm going to suggest that if the ground is kind of dry and hard, a lower pressure is going to hug the ground better and give you a little bit better contouring. But we're going to lighten it up. We're going to go to that 1600 range if we're in soft ground, if we're in wet ground, if we're in uneven ground, stony conditions, that sort of thing. That'll allow that cutter bar to lift and float over these obstacles. So, so a little bit there. And then something I have to touch on, because I see this so often, is when you guys are running your header automation, like your auto height controls and your auto hydroflex pressures in the flex modes. A common mistake I see all the time is that guys have those wrong automation systems turned on. So on the 70 series, on the corner posts, you got that icon there that looks like the hydroflex icon. It's a header with a squiggly line underneath it. Looks like the same button you would press to manually adjust the pressure. On the S series, it's on your header settings page. It's that same header icon with that squiggly line. For everything I'm saying today, that icon is bad. Avoid it. Don't touch it. Don't turn it on. Guys turn it on thinking, okay, I got a hydroflex header. I'm running on the ground. I need to turn the system on. But that is not auto height control. That is not hydroflex. That is something totally different. And I know there's guys that have been running their hydroflex headers for years using that float icon and not using actual cutter bar hydroflex capabilities. So I see this all the time when I get the fields and guys are, complaining the header's not performing the way they'd like. Well, they're not running it in technical auto mode. Okay, so whatever you're running your headers on in rigid mode for your wheat and canola, you're not changing any settings there. The same auto settings are turned on whether you're running in flex mode or rigid. We're not ever turning on that extra icon. Okay. And the last thing is just a reminder to keep your mechanical stuff in good condition. So things like auger flightings, chain tensions, to keep them tight, your feeder chain, elevator tensions, wherever there's a gap between a chain and a sprocket that touches the crop, there's opportunity for seed to get in there and you see some seed damage, and sharp edges on auger flightings and things like that will damage the seed as well. So just a short reminder there for mechanical condition of the machines. But other than that, I've probably taken up most of my time here, but I would like to field some questions. So I kind of talked a long time there and didn't listen much, but now it's your turn. So any questions, guys, fire away.
Finn.
There's got to be some.
Yeah, there definitely is. I talked to a couple guys yesterday ahead of this, and I have a couple questions that they had asked if they're too shy to bring it up.
Okay.
But okay, so here I'll throw out a couple. So you did touch on this, I think, for the most part, but we are anticipating we'll have larger plants at harvest, and we will likely have some rank beans that have lodged. What from your perspective is going to make the biggest difference trying to get those off the ground? And with that, how do we thresh out those pods without cracking or crushing seeds?
Very good question. Very common question for these conditions. So I think I did touch on that a bit, but we are going to have to get, in those situations, we're going to have to get aggressive on that head. So that's probably going to mean tilting that faceplate farther forward than we normally do, get that cutter bar angle pointed down. maybe a little farther than we normally would. Likely an aggressive reel tine adjustment. And we got to get that reel out as far forward as we can. And we have actually in situations extended some of those reel arms and pushed them forward, especially on the draper heads, to get that reel out a little bit farther, to get that lifting action happening before that cutter bar gets there. So there are a couple options there. As far as threshing out these pods, it's kind of a fine line, because you get too aggressive on threshing and you're going to damage seed, but they're not all the pods are going to be at the same stage. So it is finding that balance. So in those situations, I think on the S series, running that tailing system in the grain position
He's pretty friendly. He doesn't bother with other dogs.
It's running that tailings in the grain situation or setting should help to alleviate some of those unthreshed that are getting through the cleaning system. And instead of getting too aggressive up front on the rotor, let the tailings handle some of those. And then with the larger louver openings on the chaffer, maybe get a few more of those running through our tailing system to let the tailing system handle some of those rubbery unthreshed pods.
Awesome. I think that's going to help a lot. I know we're going to be into that situation. Just looking at all the fields in Manitoba, we've got some pretty nice sized plants that are way different to what we've had the last couple of years. So, okay, a couple more questions here. From your opinion, Scott, is it worth spending money on perforated clean grain screens?
Yes and no. I'd probably lean a little bit more towards a no. I mean, we'd love to sell parts here at John Deere, but realistically, we don't often see have dirt being a real issue in soybeans. For the edible bean growers, absolutely, that's a must. We got to run those, but strictly speaking to soybeans, I don't believe it's necessary to run the extra screens.
Okay. Yeah, it's interesting you say that. I mean, I think that's where we struggle with seed production, is because we're combining soybeans, but we're combining them for a premium. They're a seed crop, so we are almost treating them more like an edible bean crop in a way, just because they need to be treated extra gentle. Some of the main quality factors that we can control is dirt tag, and that's one thing we do want to avoid. So with that in mind, would that change your answer?
Yeah,
or
absolutely.
Would you
Okay. Most of my time isn't spent with seed growers specifically, so I guess maybe I'm speaking to a broader spectrum just from my own experience. But yeah, I mean, we are going to eliminate some of that dirt for sure with the screens, both in the feeder house as well as the auger troughs and the clean grain and tailings. So, but yeah, I mean, it does its job for sure. Yeah.
Okay, that's interesting. And kind of on that whole edible bean topic, one other question we had was an edible bean grower a few years ago had said he used small wire concaves to avoid dropping beans on shoe augers and dropping straight into the sieves. Just curious what your perspective is and what would work best for your setup. And you kind of mentioned that there maybe running a combination of small and large would be a good way to combat that.
Right. That's interesting that that came up, because yeah, I've never seen edible beans being done by small wire. I think that's asking for a lot of trouble personally. But I know there's a lot of guys growing soybeans that do run nothing but small wire, and they have good results, but they're not growing it for seed. So because you're growing it for seed, at minimum the combo with the small up front and large, but if we're really concerned about seed damage and some of those things, then large wire all across would be the best choice there.
Awesome, thank you. Does anybody else on the call have questions for Scott?
I've got one, Stacy. Brian here.
Sure. Yes, go ahead.
We typically run round bar. Would it help if we put a small wire in the first one and then 2 round bars. Would that be an option maybe to get a little bit more thrashing?
Yeah, for sure. That's definitely something you can try. If you're running round bars and want a little extra thrashing, you do have another option there. There is an insert that you can install in those round bars. So it just kind of puts a square edge in between each of those round bars. And you can install this without removing the concave. So if you've already got round bars installed in there, that might be a better option, or an easier option is just install these inserts rather than swapping out that whole concave. So it is definitely something you can try. It almost turns that round bar into a large wire capable concave.
Okay, good to know.
Yeah, that's good. All right, I'm going to give anyone else the opportunity to ask a question here quickly, and then we'll switch gears into James. Okay, crickets. I'm sure there are others out there that have some questions, but if you do have questions, feel free to shoot me a text or an email, and we can make sure that we get those passed over to Scott for sure if you don't have his contact information directly. But I have a huge page of notes here, and I'm losing my voice apparently. Excuse me. So thank you so much, Scott. This was awesome. You had such good information for us, and like so many good tips that maybe we weren't thinking about, just given that we've had so many dry years the last couple of years. We're going to really need to maybe switch our frame of thought here to adapt to these conditions here this year. So I really appreciate it. And also, you know, majority of the guys we work with do run John Deere equipment. So any like subtle change that we can make to improve quality is going to bring us up like tenfold in Manitoba specifically. So excellent information. Thank you so much. If you can, you're welcome to stay on the call here for James. And I'm going to transition it over to him to flip and talk about storage. Good morning, James. Can you hear me?
Yeah, good morning.
Awesome. Okay, so next on the agenda, we've got James Dyck from Ontario. He is what I've been calling the most knowledgeable storage expert I've ever met. James, you may remember, for those of you who called in for our spring meeting this year, had went over some storage tips for us going into the spring, warming up beans and getting them ready for moving at that time. And now we wanted to have him back and discuss things closer to harvest, how things will look going into a wet season, or potentially wet season, I should say. So James is the engineering specialist for crop systems and environment with the OMAFRA, Ontario Minister of Agriculture, Food and Rural Affairs, based in Vinland, Ontario. He was raised on a cash crop and hog farm in the Niagara region and completed his engineering degree at the University of Waterloo. He focuses mostly on best practices, innovations, environmental impacts of grain drying, storage, precision agriculture, field equipment, and on-farm energy use. So with that, I'll pass that over to James. And again, we want this to be as interactive as possible. So if you guys have questions throughout, please feel free to ask. So thanks.
Thanks, Stacy, for that intro. Yeah, some of you may remember me if you were on Corteva's spring call at the end of March. So some of this information may be similar, but we thought it was a good opportunity now, just in advance of harvest, to provide a bit of a refresher on considerations for storing your grain and drying it, especially when it comes to seed. So I'm going to touch on a few high-level things like optimal storage conditions, drying air conditions, and equilibrium moisture. These are really important to understand because with seed in particular, we're trying to dry it slowly and get the moisture where we want it to be. Then I'll touch on airflow and the importance of that, because really airflow is the only tool that we have once grain is harvested to try and manage its quality. And finally go through some more tips for success and helping you to get where you need to be. Now, I recognize a lot of you probably have a lot of experience storing grain, so much of this may be a refresher for you, but I hope I can give you some things to think about. So the first thing I always like to talk about in grain storage is a reminder that the moisture and temperature of the grain that we take off the field has a huge bearing on how well that stores. And what you're seeing in the chart here is a measure of time in days that grain can be stored. Soybeans in particular can be stored at various conditions. The message here really is that, you know, if your grain's very wet, it almost doesn't matter what the temperature is. It's going to spoil fairly quickly. So it's very important to get that grain dry, and this is why we need to either wait for it to dry down in the field or take it off early and dry it down. Now, I know this year in particular, we're with a later planting. There's the possibility that we may be faced with some later harvest and some wetter beans. So we are going to have to consider what drying looks like. Staying on the storage for a minute before we move into drying, when we look at different storage temperatures and moistures over time, this is some data that came out of the USDA handbook from the late 70s. So it's older data, but I really like it because it shows a wide range of temperatures. And what you can see here is that as far as germination goes, when we're dealing with seed, even freezing soybeans down had no impact on germ. In fact, for wetter beans, it actually preserved the germ longer. So the message here is that if you do have beans that are a little wetter, you get them off, you're concerned about getting them dry before the winter, it is okay to cool them down, keep them frozen, and then dry them when you have an opportunity, maybe in the spring. So wet beans will store well at cold temperatures without destroying the germ. Of course, at warmer temperatures, obviously the higher moisture beans, that gray line, the germ drops off very quickly, and even the very dry beans at high temperatures, that germination doesn't last as long. So something to keep in mind is the outdoor air temperature you're storing at, and certainly the moisture level of your beans when we're talking about seed. Now, a really important concept that all of us need to understand is relative humidity. And I want to take you back for a minute to maybe your high school or university science class. Just a reminder of how relative humidity works, because we talk a lot about it, but you know, sometimes it's not the easiest thing to actually understand. So if you think about the air around you, air can hold water. We all know that air absorbs water, but it can only absorb a certain amount. So if you picture air as a cup, and that cup represents the amount of water it can hold, and the size of that cup is very dependent on temperature. So if we have air at 0 degrees, it can hold a certain amount of water. So at 100% humidity, picture that cup being completely full. Now, 100% humidity, there's no more room for that air to absorb moisture, so we can't dry any grain with that air. In fact, if we tried to dry grain with that air, it would probably make the grain wetter. But we can heat up that air, and by heating up the air, we actually increase the ability of air to hold more moisture. So by heating it up, say 10 degrees, we've effectively doubled the amount of water our air can hold. And if we haven't added any water when we heat it, now we're at 50% relative humidity. We can do the same thing again, and now we're at 25% relative humidity. So kind of every 10 degrees we warm up air, you cut the relative humidity in half, roughly. And this is actually how a high temperature grain dryer works. You end up heating up the air so much that your relative humidity becomes essentially 0, and it lets you dry grain very quickly. The reason humidity is so important, though, is because grain will eventually equalize with the air around it. So when we're looking at drying beans in a bin, drying it very slowly, or maybe with a little bit of supplemental heat on it, it becomes very important for us to try and manage that humidity. Now, I know you're sitting there thinking, well, I don't have a humidity dial on my dryer. I maybe only have a temperature setting, and maybe I only have an on-off switch on my fan. Well, the beauty is that we can control humidity indirectly by heating up the air. And what you'll notice in this chart here, this chart is telling us the moisture that grain will equalize with the air around it. So the room that I'm sitting in today, you know, it's a pretty warm day in Southern Ontario. Actually, we're expecting some thunderstorms today. It's probably about 25 degrees and maybe around 50% humidity. So if we take that as as the conditions, if I had a pile of soybeans sitting on the table in front of me here, if you look up those conditions on the chart, the balance point is about 8.3% humidity, roughly. So call it 8.5 or percent humidity, pardon me, percent moisture. So if I had beans on the table in front of me at 25 degrees and 50% relative humidity, we'd be at about 8.5% moisture eventually with those beans. Now that's probably a little on the dry side. You can actually see that the sweet spot tends to be around 70% relative humidity over a really wide range of temperatures. So if we can get our humidity in the range of 70%, and when we're running our fan in a bin, we know that our moisture in those beans is eventually going to equalize to around 12 to 13%. It's not going to over dry no matter how long we run those fans if the humidity is in that range. Now, humidity bounces up and down a lot over the course of a day. The nice thing is 70% is a very achievable relative humidity, even in Southern Ontario, where we tend to be maybe a little wetter than what you guys get to in Manitoba. But it is important to watch your local weather stations, and it'll tell you whether or not you're likely to be in a good position for drying. Another thing you can do is use a tool called BinCast. It's available at decisionfarm.ca. It means you don't have to carry around that equilibrium moisture chart. And what you do is you can create a free account. You will need to do that to access the tool. That allows you to save your location on this tool. You look it up on a map, and then it will give you a weather forecast for the next 5 days of temperature and humidity and the predicted equilibrium moisture content of your crop. So you can see in this example, we started at 1 p.m. It was great drying conditions. Our EMC was about 10% or 11%. It crept up very quickly over the course of the day. So I think here we maybe had a rainstorm or something coming on. But you can do this, and it does work in Manitoba. It will depend on the reliability of your local weather station. So if you're in a more remote area, it's possible that the data won't be quite as accurate, but it's still a good way for you to take a look and use this tool to plan kind of what the next week might look like for good drying conditions, so you can know when you may or may not be able to run your fan. The reality is that airflow is the only tool we have once we get grain in a bin to try and get that moisture down. So if we do need to do drying, we're trying to actively remove moisture. We do want to have a higher airflow. You're going to want at least 1 to 2 or even more CFM, which is a cubic foot of air per minute, per bushel of grain that you have. And if you are drying in a bin, you want to keep that grain depth 10 to 12 feet or less. A couple of reasons. Number one, just the speed of drying is going to take a while to dry the grain. So if you make it too deep, it's going to take even longer. And then by keeping the grain shallow, you'll keep your static pressure low, which we'll talk about in a minute. It will take you days or even weeks to fully dry that grain, so it's not a fast process, but it is important, and it will dry eventually, as long as you're running good drying air through it. Of course, if your grain's already dry, then you just will need to aerate it. We do that to keep the temperature cool, to equalize the moisture. If there's any sort of wetter pockets, that will help spread out the moisture. You don't need as much air for that, half a CFM or less, and it'll take you hours, maybe a few days to cool that down. As you can see in the picture, grain does dry and cool from the bottom up. So the grain at the top is going to stay wet and hot the longest. So when you are drying, if you monitor the grain at the top of your bin, you can kind of see when things are breaking through. Another good idea is if you have a bin where you're going to be drying consistently, you can actually put in sampling ports every, couple of feet up the bin, stick a tube in, and that will allow you to take samples along the way. If you don't have a cable system, you can take actual samples out at various heights and kind of monitor the progress of the drying. As I mentioned, drying does take time. If we look at natural air drying using the ambient air, or maybe adding a little bit of heat, depending on the season of the year. Obviously in summertime, the weather's warmer and air's drier. It's going to dry faster than it will in October, November, December. It's going to depend a lot on your local weather, but as you can see, it will take several weeks or potentially even more later in the season. How to speed this up? You can add more airflow. You do that either with a bigger fan or by putting less grain in your bin so that you increase the effective airflow per bushel. And you can also add some heat. to reduce the humidity and increase the drying ability of that air. If you're aerating, as I mentioned, that's typically a faster process because we're not trying to dry, we're just trying to change the temperature. So it does, again, depend on how much air you have, but you're looking at more like a day to a couple of days to cool that grain down, depending on the size of your fan. Now, you will want to run your aeration fan several times over the course of the season. Kind of every time the outdoor air temperature drops 5 to 10 degrees, you want to be running that fan. And the reason for that is you're trying to keep the temperature of the grain inside pretty close to the outside. And I'll show you why in a minute. If your grain is completely dry, you can get away with less airflow. If your grain is a bit tough going into the bin, it's mostly dry, but maybe there's some wet pockets, you probably want a slightly larger fan on there just to be able to equalize that grain a little bit faster. But I've talked a lot about airflow. It's important to recognize that fans don't all perform the same. Different types of fans have very different airflow, even if they have the same size motor. So the chart on the left is just an example of 4 different 5 horsepower fans, but you can see they have very different performance. An axial fan is pretty common, very high airflow at low pressures, but they don't work well at high static pressure. And static pressure is just basically the amount of work a fan has to do against the grain that it's pushing. So if there's more grain, a deeper bin, you're going to have more static pressure. That's the chart on the right. It correlates to grain depth as well as the amount of airflow. So you can get the fan chart from your fan manufacturer, call them up, they'll give you a chart of airflow versus static pressure. And you can use the chart on the right to sort of figure out how deep your grain is and how much airflow you might have. But there's actually an easier way than that. You can just measure static pressure. You can either get a pressure gauge and stick that right into your bin plenum. You can get a gauge in inches of water. For those that don't know that measurement unit, 1 PSI is about 28 inches of water. So we are dealing with pretty low pressures here. The other way you can do it is just get a clear piece of hose, fill it with water, stick one end into your plenum and turn on the fan. And you'll see a height differential appear in that tube. And that height, if you measure that, is literally your pressure difference in inches of water, your static pressure. So 2 ways you can measure static pressure, and then you can take that measurement to your fan chart, figure out how much airflow you're actually getting. If you like computer-based tools, you can also do it online. University of Minnesota has a great little selection tool for fans. You can put in your bin diameter, how deep your grain is, and it will actually tell you, and you can actually pick your fan. They have a huge fan database, so your fan's probably in there. It'll tell you about how much airflow you're getting at various grain depths if you fill that bin up. And it'll even recommend a fan size if you are looking to build a new bin. So this is a great tool to use if you're interested in doing a bit more digging. A couple other things to keep in mind. It is important to core your bins. If you've got a flat bottom bin, this works really well to get out fines and smaller particles that tend to collect in the center when you're filling that bin. You core it out, take out a load or 2 of grain until you get a cone down that covers maybe 1/4 to 1/3 of the bin diameter. What you get at the end of that, you've gotten most of the fines out, so you have much more even airflow, much more consistent drying or aeration through that grain. Now, this doesn't work well in hopper bins because of the shape of a hopper bin. You kind of get mass flow. So I know a lot of you probably are using hopper bins, and what you'll have to do if you have a lot of fines and seeds in there, you will have to try and get those out either in the combine, as Scott just walked us through some of the options for that, or potentially with a grain cleaner if needed. But you do want to try and get the fines and stuff out because it's going to cause problems in your bin. It'll reduce the airflow by creating more static pressure, and it'll also, potentially increase some more spoilage vectors in your bin. So you really don't want to be doing that. The other thing it's important to do is level your bin. Do this after coring, and the reason for this, if you don't, you get a much deeper grain profile in the center, obviously, than you do around the outside, and grain tends to take the path of least resistance, or air rather, so you'll get more air up the outside than you will in the middle. You'll end up with a hot, wet pocket in the center of your bin that's going to take a lot longer to dry. Of course, if you do have to go in the bin, please be safe about doing that. I'll talk about that in just a minute. Just quickly, how to add heat to your bin. If you are adding heat, you can do it with a portable heater like this, or you can get a heater that'll bolt directly onto a bin fan. They're available from various suppliers, and it will depend how much airflow you have and the capacity of your heater. So you will want to pay close attention to your moisture chart. You don't want to be over drying your bins, so you want to look at what the humidity is and try and add as much heat as you need to bring that humidity down to 60 to 70%. What does that look like? Well, probably in the range of 10 to maybe 20,000 BTUs at the outside of heat per 1,000 CFM, or 3 to 6 kilowatts. And that'll reduce your humidity by somewhere between 10 and 40%, depending on the conditions. So it's a very humid day, you probably want a little more heat. If it's just a little humid, maybe a little less. So try and find a heater with some adjustment on it, but that's kind of the range you're looking for if you are looking to add some heat to a bin to speed up your drying. Now, once you do get it dry, you want to keep that grain temperature close to the outside temperature. The reason is in the fall, what happens if you've got warm grain in your bin, the grain on the outside of the bin, of course, will cool down as the weather cools down, and you've got a warm pocket in the middle. You'll get condensation near the wall, and you'll get air moving inside your bin to bring that moisture towards the middle air. Obviously, hot air rises and expands, so you will get air currents moving. If you've ever seen condensation on the inside of your bin roof, that means moisture has moved. That moisture's come from inside your bin, not outside. You don't have a leak. It means that your grain is sweating and moving moisture around. So you wind up with a wet pocket at the top. You really want to be running that fan to keep that moisture equalized and keep the temperature down. In the spring, actually, the opposite happens. The grain warms up near the outside. The cold air in the middle, again, the warmer on the outside will rise, and you'll end up getting moisture moving and dripping down into the bottom of your bin. You're not going to find that wet spot until you try and empty the bin. So it is important to keep your grain close to the outside temperature, especially if you're storing it into summer and beyond. You do probably want to be warming your bins up. Now, having said that, also try and keep them as cool as you can. You want to maintain the temperature, in that 5 to 10 degrees centigrade if you can, just to keep that grain in better storability condition. Finally, you want to be monitoring your bins frequently. So every couple of weeks, you're growing seed, that's a high value crop. So you do want to be manually checking, look with your eyes, watch for any signs of spoilage, any smells that might be a little bit off, and certainly keep written records of your inspections. Of course, there's lots of tools you can use too. Some of you may have bin temperature cables or moisture cables. That allows you to get a picture of what's going on inside your bin. The graphic on the screen you're seeing is actually a system that I believe came out of Manitoba. It's called GrainViz. What it does is you put sensors around the inside of your bin, and it gives you a three-dimensional image of the moisture throughout your bin. So obviously there's a cost to doing that, but it's pretty neat visual and can give you an idea really if you have any specific wet spots that maybe would take longer to be sensed by a cable system. Another option that's come out recently is CO2 sensors. The value here is that a CO2 sensor can typically detect spoilage sooner than a temperature cable will, because air migrates faster through a bin than temperature does. So you will, and rotting grain or spoiling grain will start to generate more CO2. So they are not as expensive, a couple of $1,000s, I think, for the kit, and because it's a sensor that hangs in your plenum. So there's different options out there, and a lot of these options can also integrate with your fan directly. So you can automate the drying process, and you can tell it, I want to maintain my moisture at such and such a level. It will run your bin fan when the weather's good for drying, and it will eventually dry your grain down. So lots of options there. Finally, just wanted to quickly touch on safety. If you do ever have to go into a bin because you've got grain that's stuck or things like that, please be very careful. Accidents happen every year. People get trapped and die. You can get trapped in seconds, and grain is like quicksand. You will not be able to dig yourself out. Just more grain keeps coming in on top of you. So if you do ever have to enter a bin, never enter when the auger's running. Always have somebody on the outside who can help you or go for help. Always wear a safety harness and a proper safety line, not just a rope around your waist. I know that can be a pain to work around, but it's much less of a pain than being trapped in grain. So please take precautions if you do ever have to get into a bin. So just in summary, it is very possible to harvest wet beans and dried. You don't need to be afraid of that, even seed soybeans. In fact, harvesting a little wetter can, or rather if you're harvesting them too dry, that is risk for damage. So harvesting them on the wet side can be beneficial from that standpoint. You can freeze seed soybeans even if they're a little wet. There's no impact on the germ there. You can dry them with low heat and keep the heat low and see if you have a heater that's adjustable, and try and maintain at least 50% relative humidity. That'll prevent splits and cracking. And finally, once your grain is dry, you do want to continually aerate it to keep the grain cool and dry. So watch your relative humidity and try and keep your grain in good shape. Air is the only tool we have, so it's important to make good use of it, and then obviously monitor your bins frequently. So that's all I had. My contact information is here. I'll make sure Stacy gets a copy of this presentation and can get it out to you. I know I put a lot of information in here, and I hope it was helpful. I hope you learned something. Please feel free to reach out to me anytime. Happy to take some questions now if there are any. I think we have a minute or two yet. And thanks for having me.
Well, thank you for coming on. I guess one thing I just wanted to reiterate before we jump into questions here is, like, if we do get into the folks on the call, if we do get into a late harvest, I think one thing we've learned from previous years when we get into scenarios like this is that drying your grain is possible, but it is not a fast process. And James mentioned that. But it is definitely something that we need to work on kind of quickly, especially on the seed production side. We're working with specific moisture contents that we're allowed to haul in at. So it is really important if you are starting to combine beans at 17% moisture, if you're loading those into the bin, to be running your fans pretty consistently as soon as you start harvest. And if you are using indirect heat source, to be very mindful that that bottom of the bin can dry fairly quickly. So like James mentioned, make sure that if you are using that, to watch it and turn that bin once you feel like that bottom has gotten to sufficient moisture. So I thought that was a really good tip, because I do think that this is kind of bringing me back to some of the years where we ran into this before, and we did have to use indirect heat source, and it works great, but it does take some time. One thing, James, that you mentioned there was running fans when you're heating things up to bring them in the spring. But what's your take on, if we're loading beans into the bin here early October and we're hauling in say early December, do you think that it's important for us, if we've frozen those beans down during that time, to run the fans right before we haul them in?
So two things, I guess. One is, it's worthwhile to make sure that your beans are in good shape and you don't have any wet pockets or hot pockets before you bring it in. So the reality is, though, if you're bringing them in December, January, you can only work with the temperature of the air around you. So I certainly wouldn't recommend, trying to warm them up to 15 or 20 degrees with a big heater on it, because you're going to end up, drying your beans more than you expected to by doing that. So I think it's fine to, from a management standpoint, it's fine to haul them in. If the weather outside is cold, it's fine to haul your beans cold, because they're probably going into storage at Corteva's facility or wherever, and going to be cooled back down anyway. So I don't think there's any issue from a storability standpoint to do that. It's more about being conscious of the weather around you. If it's really warm outside, that's when you want to be careful. Because if you're trying to haul frozen beans in warm weather, guys talk about augers literally dripping with water as they're moving, cold grain through an auger in 20-degree heat. So I don't know that I'd recommend doing that either. But if you're hauling in winter, yeah, you can keep the grain cold.
Nice. Thank you. Does anybody else on the call have any questions for James? Sorry, we're kind of running over time.
as I said, my contact information's here. So, feel free to reach out as you've got situations or questions, or as you think about this information over the coming days. I'm always happy to chat.
James,
Appreciate that.
We have one question here. Can
Yeah,
you
go
hear
ahead.
us?
Yeah.
Yeah, James, Manitoba has ample supplies of hydroelectric power, and I see very little work being done with using some kind of an electric heater to, move your temperature up, say 5 degrees C. Are you seeing anything in the industry there that's leaning towards that?
So that's a great question. I'll try and answer it quickly. One of the challenges with electric heat, and I don't know Manitoba's power pricing structure, but in Ontario here, the price of electricity is quite a bit more expensive than natural gas or propane, even propane, certainly natural gas, but even more than propane. When you look at it on a dollars per energy unit basis, so dollars per BTU or dollars per kilowatt hour, comparatively, it costs a lot more for the same amount of heat out of an electric heater. So that's one reason why there hasn't been a lot. Having said that, there have been a couple projects in Ontario looking at using heat pumps, which for those that don't know is kind of an air conditioner working in reverse. Instead of trying to cool air down, you're pulling heat out of somewhere and dumping it into your airstream. So the advantage there is you get efficiencies that are a lot higher. Technically efficiencies of 400 to 600%, because you're not actually producing heat, you're just moving it from one area to another. So I think there's a lot of potential there. And it's a lower grade heat, so it works really well for indirect heating like this. No commercial systems that I'm aware of, but some guys have played with it on their own. And there is actually an ongoing research project right now that's being funded by Grain Farmers of Ontario that's looking at potentially a larger scale system. So hopefully have some results to share on that in a year or two. Hope that answers your question. But it is very possible to use electric heat if you have reasonable power pricing and don't have good access to other fuels. Electric can definitely work. It's just a matter of the price of it.
Great question. Anybody else have anything that they need from James or Scott? Crickets. Everyone's going for a refill on their coffee cup. Well, thank you guys to everyone who called in here this morning. Really appreciate you taking the time to learn from these two experts. We've got a lot of good information on the call here today. So like both presenters had mentioned, we'll make sure to get this contact information available to you. So if you need anything in season, you're able to reach out to them directly or through myself. So anyways, you guys take care, and thank you for calling in. To the Manitoba growers on the call, you'll definitely hear from me before we get into the harvest season, but to everybody else, have a safe and good harvest season. So thank you.